This video is about solving absolute value equations. Now to start off, let's make sure that we all understand what absolute value is. By definition, absolute value is the distance that a value is from zero. Okay? So I have this thing that I like to refer to as the definition of absolute. And it says the absolute value of x equals a means that x is equal to a or x is equal to the opposite of a. These two pieces right here with or in between being the key. All right? So you're going to hear me say apply the definition. What I'm applying is exactly this part that I just highlighted. Okay? So how do I solve an absolute value equation? First thing I got to do is solve for the absolute value. That means anything on the same side of the equal sign as the absolute value sticks, okay, I got to move to the other side. So our goal is we have to have the absolute value all by itself first. Then we're going to apply the definition of absolute value, which means, yes, we have to write an equation. X is equal to a or x is equal to the opposite of a. Then we're going to solve the remaining equations. Yes, equations. There should be two of them. Okay? All right. So let's jump right in here. In this first example, I've got the absolute value of 2x minus 1 is equal to 5. This absolute value is an equation, equal sign, and it is already solved for the absolute value. Remember, that was step 1 there. I'm now going to apply the definition of absolute value. And the definition of absolute value says what's in the sticks, 2x minus 1, is equal to what's given, or what's in the sticks, 2x minus 1, is equal to the opposite of what's given. Now please notice, a lot of tendency that people have, a mistake that is very common, is people change that minus 1 to a plus 1 because they say, well, absolute value always means positive. That's not what absolute value means. It is a positive distance, yes. But what we are trying to find is every value that we could take the absolute value of and get 5 as an answer. All right? So in other words, we know that 5 and negative 5, if you take the absolute value of either one of them, you get 5 for an answer. We're trying to figure out what makes 2x minus 1 equal to 5, or what makes 2x minus 1 equal to negative 5. Now, we solve each of these separately. When I add 1, so I get 2x is equal to 6. Divide by 2, x is equal to 3. I solve the second one, add 1, so I get 2x is equal to negative 4. Divide by 2, x is equal to negative 2. I know that my final solution here is x is going to be equal to negative 2 and 3. Okay? I just wrote them from smallest to largest. It really doesn't matter. Okay, let's try to solve this second one now. It is solved for the absolute value, so I'm ready to apply the definition. The definition says 3x plus 2 has to be equal to 4, or what makes 3x plus 2 equal to the opposite of 4? We know that the absolute value of 4 is 4. We know that the absolute value of negative 4 is 4. That's what we're trying to find here, the values of the variable that will give us 4 or negative 4. Solve the first one. Subtract 2, so I get 3x is equal to 2. Divide by 3, I get x is 2/3. Do not write this as a decimal. 2/3 is the way we want the answers written. All right? We don't want a decimal approximation. On the second one, we're going to subtract 2. I get 3x is equal to negative 6. Divide by 3, I get x is negative 2. So my solution would be negative 2 and 2/3 would be my second solution. Yes, the work should accompany the solution. All right, so take a look at this one now. On this third example here, we've got stuff going on outside the absolute value. So the first thing that I need to do on this problem is solve for the absolute value. So if I solve for the absolute value here, I know I need to add 1 to both sides. This gives me 3 absolute x plus 2 is equal to 9. Now, sometimes people want to distribute that 3 in. Don't. You can't. All right? Don't think that way. Think of those absolute value sticks as walls that you can't penetrate. The definition tears the walls down. But what I can do, because 3 is multiplying the absolute, I can divide both sides by 3. And that tells me that the absolute of x plus 2 is equal to 3. This is now the absolute value equation that we can apply the definition to. So x plus 2 equals 3, or x plus 2 equals the opposite of 3, or negative 3. Solve each one. On the first one, I'm going to subtract 2. I get x is 1. Second one, I subtract 2. I get x is negative 5. My final solution would be x is equal to negative 5 or 1. All right, take a look at number 4 here. Again, same idea. First thing I'm going to do, subtract 3. 2 absolute x plus 9 is equal to 4. I don't want to distribute. Divide both sides by 2. I get absolute of x plus 9 is equal to 2. I can now apply the definition that says x plus 9 is equal to 2, or x plus 9 is equal to the opposite, or negative. Subtract 9 from both sides. I get x is negative 7. Second equation, subtract 9 from both sides. I get x is negative 11. I'm going to write my final solution as x is equal to negative 11 and negative 7. And again, guys, notice we haven't really talked about it in this lesson, but what is the significance of those two numbers? I can plug either one of those numbers into the original equation, and I would get balance. The left side would equal the right side. Now, I'm going to introduce a new term to us now, something that is called an extraneous solution. All right? This is a solution that you get from doing the work. So you solve an equation, or in this case, an absolute value equation. You solve it, but the problem is it makes the equation, when you substitute it back in, it makes it false. So it was a solution, but it's not really a solution. Okay? Hopefully this will make a little bit more sense once I go through a couple examples with you guys. All right. In this problem, on the left side, notice that you have the absolute value isolated. All right? This tells me I can apply the definition. The definition says 3x plus 2 is equal to 4x plus 5, or 3x plus 2, here's where you got to be careful, is equal to the opposite of 4x plus 5. Now, the opposite of 4x plus 5 would be negative 4x minus 5. I'm distributing a negative 1 through that right side. Now, if you notice, this was the first example that we had that had variables both in the absolute and outside the absolute. All right? That actually indicates to me, watch out, you may or may not, but chances are you're probably going to have an extraneous solution. The problem is you don't know which one is going to give you the extraneous solution. So I'm going to solve each one now. I'm going to subtract 4x, so I have negative 1x plus 2 is equal to 5. I'm going to subtract 2, so negative 1x is equal to 3, and then divide by negative 1, and I get x is negative 3. All right? I'm going to solve the second one. By adding 4x, I get 7x plus 2 is equal to negative 5. I'm going to subtract 2, so 7x is equal to negative 7. And when I divide by 7, I get x is equal to negative 1. Now, I got two solutions by following the definition. All right? But now I need to verify that they work. If I take negative 3, and here, guys, here's the trick on this. All you got to do is worry about substituting it there. We could plug it in on both sides and make sure that we have equation balance. But if I plug negative 3 in to that x, I would have negative 12 plus 5 or negative 7. Can the absolute value of something ever give us a negative result? No. So I know that this solution that we found is actually an extraneous solution. It doesn't work when you plug it in. All right? Well, what about negative 1? That's a negative number. Isn't that going to mess it up? Well, let's see. What is 4 times negative 1? That's negative 4 plus 5. That's positive 1. I'm betting that this one's going to work. And if I wanted to check it further, plug it into the original. So I have negative 3 plus 2, or negative 1. Absolute value of negative 1 is 1. It works. Our final solution would be only x is negative 1. Even though we found two solutions, only one makes the equation true. All right, so let's try one more like this just to make sure you guys got it. 5x minus 2 is solved. It's already inside the absolute value. We're good. I'm going to apply the definition that says 5x minus 2 equals 7x plus 14, or 5x minus 2 is equal to the opposite of 7x plus 14, which would be negative 7x minus 14. Solve the first one by subtracting 7x. Negative 2x minus 2 is equal to 14. I'm going to add 2, so negative 2x is equal to 16. Divide by negative 2, I get x is negative 8. Solve the second the second equation. I'm going to add 7x to both sides, so 12x minus 2 is equal to negative 14. Add 2, 12x is negative 12. Divide by 12, x is negative 1. And now I need to verify that both of these are going to work. But again, remember, I showed you guys the shortcut here. If I substitute those x's in there, and this right side of the equal sign is positive, I'm confident that it worked. If I plug it in and the right side of the equal sign is negative, doesn't work. It's extraneous. If I substitute negative 8 in there, that's negative 56 plus 14. That's a negative number. This is extraneous. Doesn't work. An absolute value has to give me a positive answer because it represents the distance that a number is from 0. If I substitute negative 1 in, I get negative 7 plus 14. That's positive 7. That works. There's my answer. X is equal to negative 1. Hope this helps. Let me know if you guys have any questions. Good luck.